Hello, I'm Mr. Whitehead and I'm here to teach this maths lesson. You need a couple of things, a pen or pencil and some paper, and the practice activity from last lesson. Press pause while you collect those bits and come back when you're ready to carry on. Okay, hold up your activities for me. Let me take a look and see how you got on with this task. We were looking for missing symbols, inequality symbols. We were looking for missing minuends, and in the challenge, a missing subtrahend. I wonder if you managed to have a go at the challenge, if you were able to think of a reason for why this was picked as a challenge. What was the same, what was different here compared to the questions C and D. Let's see how you got on. Okay, part A. This is the symbol that I got. Is it the same as yours? How did you choose that symbol? This is how I approached it. I rounded each of the numbers to the nearest whole number. Then, looking at the expression on the left, I worked out that it was going to be, the difference, if I calculated it, would be greater than 60. Whereas on the right, based on the rounded minuend and subtrahend, if I did calculate it, the difference I thought is going to be greater than 20. So then if I compared the 60 and 20 as my approximate differences, I was able to fill in the missing symbol. I wonder how you approached it. What did you get for B? I got the less than symbol. Did you get the same? And how did you find it? What did you do to find the missing symbol? Here's what I did. Again, I used rounding to approximate. I didn't calculate with the numbers as they are in the expressions. I rounded them all to the nearest 100. Then I looked at the minuends. The minuend from the left-hand expression is less than the minuend from the right-hand expression. I looked at the subtrahends and thought they're approximately equal. So I used the approximately equal to symbol in my jottings there. 900 is about the same as 1000. With that in mind, if I'm subtracting about the same amount from each of those rounded minuends, then the difference that I would have from the left-hand expression would be less than the difference from the right-hand expression, because those minuends, the minuend from the left is less than the minuend from the right. Okay, C, we moved on to balanced equations. We need to ensure that the value of the expression on the left and the expression on the right are the same. Now I approached this with a written subtraction for the right-hand expression. I found the difference between those two numbers to be 20.886. There was an opportunity here to adjust the minuend and subtrahend by the same amount to make the written subtraction easier. I used the numbers as they are, perhaps you did too, but maybe you used some of the previous learning to make changes, the same change to each of those numbers to keep the difference the same. Once I'd calculated the right-hand side, I used that to help find the unknown minuend. I added 20.886, the difference from the right-hand side, I added that to the subtrahend from the left-hand side to find the missing minuend, 33.353. D, still looking for a missing minuend. This time it's from the right-hand side. How did you approach it? The same way as for C, or in a different way? I did some calculating again from the left-hand side this time. I found the difference between those two numbers, 5,765. Was tempted to fill in the missing minuend box, but of course I need that to be larger than the subtrahend. It doesn't make sense. So I stopped, rethought, and added it instead to 25,671, which gave me the missing minuend, 31,436. Perhaps you noticed a way to find that missing minuend without using a written subtraction. If we look closely at the subtrahends from each of those expressions, there's an increase of 10,000. if we apply that increase to the minuends, we find the missing minuend without a written subtraction. Challenge. What did you get? I got 24,314. How did you get it? This time, I noticed when I looked at the minuends, there was an increase of 16,000. I applied that same increase to the subtrahend to find 24,314. I wonder if anyone found that missing number using written subtraction. Maybe something like this. Calculating the difference from the left-hand side expression and then subtracting that from the known minuend to find the missing subtrahend. Now, we were asked at this point, why has this problem been chosen for the challenge? And if I bring up D, in D we were finding an unknown. We were finding an unknown in the challenge as well, but what was different there? In one we're looking for a missing subtrahend, and in the other, in D, a missing minuend. And what difference did that make then to the calculation? In the challenge, once we had found the difference from the left-hand expression, we had to subtract that from the minuend in the unknown expression, in the expression with an unknown number. Whereas in D, once we had found the difference from the known minuend and subtrahend, we had to add that to the subtrahend to help us find the unknown minuend. So depending on which part of the subtraction you're looking for, it determines, in this case, whether we're subtracting or adding to help find the missing number. This lesson, we're going to be focusing on balancing equations. You've seen this image before and used the generalization before as well. Read it aloud with me on 3 and fill in the missing word. 1, 2, 3. The value of the expressions on each side of the equals symbol must be the same. Today we're going to look at balancing equations where there are 2 addition expressions or where there are 2 subtraction expressions. Let's take a look at 3 problems together. Here's the first one. Give it a read with me. 1, 2, 3. 2 classes raised the same amount of money each from a cake sale and a sponsored walk. Year 5 raised £63.56 from their cake sale and £56.44 from the walk. Year 6 raised £59.84 from their cake sale. How much did they raise from their sponsored walk? Press pause, have a go at drawing a bar model to represent the information from this problem. Press play again and we can carry on. Ready? Let me show you my bar models. 2 classes, Year 5 and Year 6, raise the same amount of money. So 2 bars that are equal. Let me plot Year 5's information. £63.56 from their cake sale and £56.44 from their walk. Year 6, £59.84 from their cake sale. How much did they raise from their sponsored walk? Press pause again. This time have a go at taking the information from the bar models and plotting them in a part-whole diagram or diagrams. Press pause, then play again when you're ready to take a look at my part-whole diagrams. Ready? Okay, here's my first part-whole diagram. What does the red amount represent? Year 5's cake sale. The blue, Year 5's walk, and the black, it's going to represent the whole, the sum of those 2 parts. Do we know what that is yet? No. Year 6, what does the green represent? Their cake sale. What does the part that's black, what's that going to represent? The sponsored walk. What's going to be the same across the two part whole diagrams, across the two classes? The wholes will be the same, and they're made up of two different parts. Press pause again. This time, have a go at turning this information and representing it using equations. Press pause, press play again when you're ready. How did you get on? Hold up the paper, let me take a look at the equations. We've got one equation, two equations. Take a look. So I represented year 5 using one equation, and year 6 using its own equation as well. Now I want us to have a think about how we can bring those two equations together to form one balanced equation. Take a look at this image. If you haven't already, decide where you would or how you would arrange those two equations to form just one. If you want to, press pause and have a go, or carry on with me now as I show you where they would go. So year 5's expression on the left would be balanced with year 6's expression on the right, with the equals symbol between the two. I know that the classes raised the same amount of money. The sums of the left and the right expressions will be the same. The equation will be balanced. Have a go now at solving the problem. We've got the equations that we formed using part-whole diagrams, bar models. Having read the problem, now have a go at solving it. Press play again when you're ready. How did you get on? How did you approach the problem? How did you find the unknown addend? This is how I did it. I added the two known addends from the left-hand side, found the sum of £120. Now I know that the sum on each side must be the same value. So £59.84 add the unknown addend must equal 120. I used a number line to find the orange addend. £59.84 add 16p will reach £60. From 60 to 120, £60. So combining the £60, the 16p, £60, 16 as the unknown addend. I wonder now if you can pause and have a go at filling in the missing parts from the equations, from the part-whole diagrams, with the correct values. Press pause, then play, and we'll take a look. Ready? Okay, so the question marks from the whole on the left-hand side from year 5, £120, and from year 6, the same, £120, and then the orange addend, £60, 16. How about from the one equation? The orange addend is the only part to fill in here, and we work that out to be £60, 16. Second problem, let's have a read of it together on 3. 1, 2, 3. Year 5 had 10 metres of rope for their den building project. They use 4.63 metres of it. Year 6 had 12 metres of rope and use some of it for their den. Both classes have the same amount of rope left. How much rope did Year 6 use? Press pause and have a go at representing the information from this problem using part-whole diagrams. Press play when you're ready. Ready? Hold up your part-whole diagrams. Let's take a quick look. Let me show you the ones that I've drawn. So, Year 5 had 10 metres of rope. They used 4.63 metres of it. We don't know how much is left. Year 6 had 12 meters of rope. They have the same amount left as year 5, so that's that part, and we want to know how much they used, so that's the part on the right. Now, importantly, both classes have the same amount of rope left, so we could represent our part-hole diagrams like this, so that middle part on the bottom row that's shared by both year 5 and 6, that represents the same value. It represents the amount of rope that both classes had left. We know year 5 used 4.63 meters. We need to answer the problem, the question, by saying how much year 6 used. Okay, so I now want you to have a go at writing an equation to represent the information from the problem. Aim for one equation. Visualize the triangle with the equal to symbol above it and two expressions where the value of each will be the same. Press pause, then press play again when you're ready. Ready? How did you get on? Hold up your paper, let me take a look at the equations that you've written. Here's my one. Year 5's expression on the left and year 6's expression on the right. Now think carefully about the orange part, so the subtrahend. Think about what that represents from the problem. Is it the amount that year 6 used? Is it the amount that year 6 had left? It's the amount that they used. The amount they had left is the same as the amount that year 5 had left. That's the difference from each of the expressions. And we can't see that as a number. We can only see what they started with and what they used. Really important to keep that in mind. Press pause and have a go now at solving the problem. How much rope did year 6 use? Press play again when you're ready. How did you get on? Have you found out how much rope year 6 used? That's the important part. That orange subtrahend is the answer to our problem. And to reach that answer, we probably have found out how much rope each class has left, and it's the same amount for each of them, but it's the amount that year 6 used that will give us the final answer to the problem. Now, I used a written subtraction to get me started. So I subtracted 4.63 from 10. 5.37 is the amount of rope that year 5 had left. Now there was a lot of regrouping in that subtraction. Perhaps a more efficient and smarter way to work would have been to count up from 4.63 to 10. 5.37 is the difference between those two numbers. So the difference is the same whichever approach you take there, and maybe you took a different approach to either of those as well. Once we've worked that out, it helps us to find out how much rope year 6 used. If we know that they had 5.37 left, because it's the same amount left on each of the classes, we know that, we can subtract it from 12 to find out how much rope they used, 6.63. Again, could have counted up from 5.37 to 12 to find that difference in a more smarter, more efficient way. So 6.63 is the amount of rope that year 6 used. Now, perhaps some of you found that missing subtrahend by looking closely for any relationships between the minuends to help you find it. And when we look at 10 and 12, it's been an increase of 2. And we've learned that if we apply that same change to our subtrahends, the difference will be kept the same. And in this problem, the difference is the amount of rope left, which we know has to be the same. Okay, final problem. Both lawns have the same perimeter. How long is the side marked X? Press pause and have a go. See if you can find an equation that would help. have a go at solving it. Then come back and we'll take a look together. Ready? So, perimeter. What do we know about perimeter? It's the total distance around the outside of a shape or an amount of space. So I wonder, did anybody start off by visualizing or filling in the missing parts to those lawns? And therefore, did anyone calculate using all of those dimensions? Something like this and this. So we'd have two addends to find there. Now, I wonder if anyone perhaps was working a bit more efficiently and considered, well, actually, we could just use these parts and find half the perimeter. If we know half the perimeter using the addends on the left, it can help us to find the missing addend from the right. Half of the perimeter from each lawn will be the same because the perimeter of each lawn is the same. Press pause now, if you haven't already, and have a go at finding the value of x using this balanced equation. Are you ready? So, how did you get on? How did you find the value of x? Hold up your paper, let me take a look at how you've used this balanced equation. Okay, so when I first looked at this, I had a go at looking for any patterns, relationships between the addends of the two expressions, and I noticed an increase of 300 for the first addends. Now I know that the sum of each expression must be the same because both lawns have the same perimeter. So if I want the sum to stay the same, but one of the addends has increased, the other addend needs to decrease by the same amount. So x is equal to 820, subtract 300, 520 meters. Okay, we have worked through 3 different problems today, all to do with balanced equations. Sometimes we've been balancing 2 addition expressions, sometimes 2 subtraction expressions. We know that the value must be the same on each side of that equals symbol. I'm leaving you with a problem that's similar to the one we just worked through. If you're ready for a challenge, then I challenge you to find more than one way to solve the value of x. In a moment, you can press pause, take a picture of the screen, or copy down the task. Your teacher will go through it with you at the start of the next lesson. Thank you for all of your hard work. Bye.